Hey everybody, this is Larry. This is me going with Q4 of the Bi-Weekly Contest 166. Maximize alternating sum using swaps. Hit the like button, hit the subscribe button, join me in Discord. Let me know what you think about this one. This one I solved in about 6 minutes, so I didn't think it was too bad. For a hard problem, this is a little bit on the easier side, especially if you have the foundation and the practice. The key thing to note is that you could do an infinite number of swaps, and if you have an infinite number of swaps, then you're able to basically you can think about it as if there are or swaps are kind of transitive, right? Meaning that if you can swap A and B and C, then that means that you can swap A and C. And then from that, the first thing to know about that then is that any two indexes, you could kind of combine all the swaps together, and when you quote unquote combine the swaps together, and we'll go over what that means in a second, but when you combine the swaps together, then you're able to put any numbers that are in that combination, in that union, if you want to call it that, any number from there, and then as a result, well, we're trying to maximize this alternating sum. So that means that you want to, if the index is odd, if the index is even, you add it, and if the index is odd, you subtract it. So then if the index is odd, if the index is even, you want to maximize the number that you're using, and then if the index is odd, you want to minimize the number that you're using because you're subtracting to maximize the sum. So that part is the greedy, that is pretty straightforward, right? So I think a lot of people got this one as a result, because I don't think it is. I think the concepts are pretty straightforward once you've done it, right? And especially if you practice union find or even connected components. Really, maybe I should have said connected components first, which is that, yeah, if A is connected to B and B is connected to C, then A is connected to C, and you could use any number inside that component, right? That's the core part of that idea. I did it with union find. You could also do it with BFS or DFS, either one, right? And yeah. But this is the union find code. It's my standard code. Maybe I need to copy paste this instead, so that it's slightly faster, because I always type it out. But I mean, it's like 8 lines of code. It's not a big deal. Though that said, I say it's not a big deal, but I did have a typo for some reason that cost me like a couple of seconds. So even on top of typing, it cost me time from time to time. So maybe no bueno. But in any case, this is union find. I'm not going over it in this video because this is a Q4. This is fundamental in general in competitive programming, maybe even interviews. So not gonna go over that in detail, but you could pretend that this is a black box where you have the union find and the union, right? And then now for every swap, we just union X and Y into one index. And then now we look at, for every index, we look at the root of that union, and then we just kind of put the numbers in it. It means that basically of all the numbers that are for every index that's in the same component, we just basically gather the numbers together right into a list, and then from that we could sort it, right? And I just put it on queue. The reason why I put it on a queue or deck is so that we can remove from the because we want something that we want to remove from the beginning and the end, right? Meaning the min and the max, and that's it. And here I even have a note for myself, even though I did make a mistake and added by accident at the end. But yeah, if it's even, we want to add, so we want to maximize it. If it's subtract, or if it's odd, we want to subtract, so we don't want to minimize it, right? So yeah, if it's even, add, odd, subtract. So here we get the max, that's what the pop is for. Otherwise, we get the min, which is the pop left, and that's it. Yeah, that's it. That's all I have for this one, pretty much. Let's go over the complexity really quickly. Union find, let's just for this video, let's just say that's O of n time, O of 1 per core. There's some more nuance there, but it's fine. I know reverse inverse Ackermann function, etc., etc. It's fine. All right. So yeah, so that means that for each swap, this is going to be O of 1 for each swap, pretty free. And you find is path compressed, so this is also O of 1, especially by the later times you use it, right? So yeah, this is all of one, put in the list. This is the only part that is going to be n log n, right? It's n log n because the worst case, if you can imagine it, is just putting all the numbers in the same swap. So then it's going to be n log n because you sort it, and then you have a deck. And then yeah, and then this part is just all of one, right? For each number, for each index. So that means that actually this really small piece of the small piece of code is basically the complexity n log n right here, and that's it. That's all I have for this one. Let me know what you think. Thanks for watching, and you can watch me solve it live in the contest now. Okay, because it's just so easy. The examples are not very good with respect to like how full I think it is. So apparently I'm still ranked 2000 without doing the Q4, so let's take a look. So maybe it's a easier Q4. Maximum alternate sum, alternating sum using swaps. Different. Oh, adding. You want to do swaps? How many swaps are there? Everything is big, so there's no like weird DP. Well, maybe there is, but no standard DP. Maybe there is a weird DP. Okay, you have a swap map. How many times can we swap? Any number of times. So then it's going to be union fine-ish. Yeah, it's going to be union fine, greedy, and I think we're good, right? Yeah, okay. I mean, this is, yeah, I could see why this is easy. Or like easy enough for a lot of people to solve. Right. Right. Oh, man, I'm like really not good today. Just like a little bit sloppy mentally. Okay, right, and then now for X, Y, and swaps, we just, well, union them, right? Okay. And then now, okay, yeah. Then now we just store them, right? So here we go. I call everything F, which is maybe not a great thing. Actually, we want this to be a Q, but maybe we could do that later. Yeah, for I range of n, we go f of you find of I dot append nums of I, right? Okay. And then now for key in f of keys, do f of key. It's not a sorted list. I mean, we could do a sorted list, but I think that's slower. So we want queues, right? It's not right. Deck. F of Q of K is equal to F of K. Okay. And then now we're Gucci. K is still you fine. Okay, so then now we have to do it. What is it? Add even max even subtract odd min odd, right? So that means that now, okay. So yeah, and then we have a score. Go, okay. If I don't know why I have to think about this. We already, I always said it. Maximize. So the score Q sub u find of I run the max of it, so it's going to be pop right, or just regular pop. Oh, score pop left, and we should be good. Was it 4 and then some big numbers? Okay. Did I mess this up? Oh, it's not. Whoops. That's clearly not right. Why is that? Pop left, pop right. No, that should be okay, maybe. Should be every number. So then this is. Just print score real quick. 3. So we want 3 in the first number. Did I mess this up? Is this one indexed or something weird? And I didn't. No, it's 0 indexed. I don't get it. Okay, so you take the 3, you take the 2. Oh, you subtract. Oops, dumbass. Okay, sorry, I'm dumb out with myself. I usually don't curse, but that was just pretty dumb. Okay, okay, so it looks okay. Let's double check complexity. Don't know how I messed this up, but okay, let's go to submit. Okay, pretty straightforward, I think. Thanks for watching, everybody. Hit the like button, hit the subscribe button, join me in Discord. Let me know what you think about this problem, this contest, everything in between. Stay good, stay healthy, to good mental health. I'll see y'all later and take care. Bye-bye.